Welcome to this demonstration of Nature Robots Mission Control. In this video, we will show how to use Mission Control, with a special focus on the Field Row Creator. First, we create a new environment. In this example, we are using our test field in Calcrease. Mission Control follows a modular approach. This means users can work with different tools depending on the task they want to perform. The main tools shown here are the Field Coverage Planner, the Manual Editing Tool, and the Field Row Creator. In this part of the demonstration, we focus on the Field Row Creator. The first step is to define the field boundary. In practical use, this boundary would usually be recorded by driving the robot around the field. The collected boundary data could then be imported directly into Nature Robots Mission Control. For this demonstration, however, we draw the geofence manually by clicking points on the map. The recommended workflow is still to import boundaries whenever field data is already available. After setting up the geofence, we move on to defining the crop rows. First, we mark the first row of the bed. Then, we mark the last row of the same bed. These two reference rows help the system understand the row orientation and the structure of the field bed. Next, we enter the row distance. In most agricultural settings, the row distance is already known once the rows have been created in the field. After entering the row distance, we continue to the next step and generate the field rows. Mission Control calculates the row distance based on the first and last row. The user can then choose whether to accept this calculated value or adjust it. Once confirmed, the extrapolated rows are created automatically. You can now see the generated rows inside the field boundary. Even after the rows have been created, the layout remains editable. The user can still move the field corners, adjust the field borders, and refine the shape of the field. Now we create a second bed within the same field environment. This is one of the main purposes of the Field Row Creator. It allows users to work with multiple beds inside one field. The workflow is similar to the previous example. We define the bed, set the direction, enter the row distance, and generate the rows. In this case, the direction of the bed is different. Instead of a horizontal orientation, this bed is arranged vertically. Again, we enter the row distance and generate the field rows. The same notification appears, allowing the user to review and confirm the calculated row distance. After the rows are generated, the user can inspect the allowed driving directions within the field. The borders can still be changed afterwards, making it possible to extend, reshape, or refine the bed even after the initial generation. Once the field structure is ready, the field can be saved. Next, we switch to the Manual Editing Tool. This shows another important principle of Mission Control. A field environment is not locked to one single module. After creating the field in the Field Row Creator, users can continue editing the same environment in other tools. Inside the Manual Editing Tool, we can adjust the edge direction. For example, the driving direction can be changed from bidirectional to monodirectional. It is also possible to switch the driving direction of specific edges. This gives the user a high level of flexibility when preparing the mission. In this example, we connect the different beds inside the field. This tells the robot what should happen after it finishes one bed. The robot can then continue from one bed to the next according to the planned graph. We can also change the path strategy. For example, we can switch to an inter-row strategy depending on how the robot should move through the field. Next, we create a waypoint. A waypoint can be used for a specific task, such as refueling, unloading, or connecting to another operational step. This makes it possible to add practical field actions directly into the mission graph. The Manual Editing Tool allows many detailed adjustments. We can change allowed directions, switch row directions, adjust the row strategy, and adapt the mission to the specific use case. We can also switch the map type, for example from satellite view to a different map layer. For specific points, we can add attributes with a key and a value. In this example, a point can be marked as a resource, such as a truck. After making the adjustments, we save the graph. We can also select specific rows, label them, assign strategies, and add attributes. This is useful when different rows require different tasks or different machine behavior. After that, we can click Start. We can group and select different rows, select the edges, and assign tasks to them. In this demonstration, you can see example tasks such as data recording or laser weeding. These are dummy tasks for the demonstration, but the system is flexible. In the future, different task types can be implemented depending on the application and the machine setup. Once the rows, edges, strategies, and tasks are configured, the mission can be started. Next, we take a short look at the Field Coverage Planner. In this module, we can start a new field, create a new environment, and plan how the robot should cover the entire field area. The Field Coverage Planner is especially useful when the goal is not only to follow existing rows, but to generate complete trajectories for field coverage. First, we define the headland settings. In this example, we use 3 headlands. Then we roughly define the field boundaries on the map. Next, we configure the planning settings. For example, we can change the infield angle and adjust how the trajectories should be generated. Mission Control provides different configuration options depending on the planning requirements. After configuring the planner, we generate the trajectories. These trajectories describe how the robot will drive over the field, how the rows are covered, and how the turns are planned. The different colors show the timing and sequence of the field operation. They indicate when each row or area is worked during the planned mission. We can zoom and scroll through the plan to inspect the details. When we zoom in, we can see the specific turn types and how the robot is expected to move from one trajectory to the next. After reviewing the plan, we can download the planned field and transfer it to the machine or tractor. We can also save the plan in Mission Control. Finally, we can switch between Simple Mode and Expert Mode. Simple Mode gives a cleaner interface for standard operation, while Expert Mode provides more detailed planning options for advanced adjustments. This concludes the demonstration of Nature Robots Mission Control. We have seen how to set up an environment, generate rows with the Field Row Creator, refine the mission in the manual editing tool, assign strategies and tasks, and create field trajectories with the Field Coverage Planner. With this modular workflow, Mission Control helps users plan, edit, and execute autonomous field operations in a flexible and structured way.